Good afternoon, everyone. Thank you for joining us today for our second day of Energy Week with the topic of smart electricity. And I'm Feli, and then I will be the moderator for today's session. And then joining us today is Mr. Hazril Izan Bahar as the Director of Digital Services Sustainable Energy Development Authority in Malaysia. And then also Ms. Annisa Chairani as the General Manager of Marketing and Business Development of T.En.Hazril. Today's session will be divided into three parts. The first part will be conducted with me by Mr. Hazril, and then the second part will be conducted by Ms. Annisa, and then the last part will be the Q&A session with both of our speakers. And then for the questions, you can put it in the chat box. And for this whole of webinar session will be conducted in English. Maybe now we can start off with the first session with Mr. Hazril Izan Bahar. The time is yours.
Okay, thanks. Okay, Assalamualaikum and good morning. Thank you very much, especially to ITB for inviting me for this webinar and also everyone who is attending. My name is Hazril Izan bin Bahari. I'm from Sustainable Energy Development Authority of Malaysia, or we also call it SEDA. And I am a director of Digital Services Division, and my background is ICT. A brief introduction about SEDA. We are a government agency reporting to the Ministry of Energy, and we were established in September 2011 under the SEDA Act. Our primary function to implement the feed-in tariff scheme and to advise the Minister on issues related to sustainable energy. Okay, firstly, I will just brief about introduction about the power grid. Okay, I hope everyone can see. Okay, the power grid is the infrastructure that transport electricity from where it is generated to the consumers. Most electricity grids are based on one-way interaction from the stages of generation to consumption. The grid follows a top-down model where electricity is generated in the centralized unit, then step up using a power transformer and a transmission substation. Then through a distribution substation and power transmission lines, the power reaches the consumer in a one-way flow with no feedback from the consumer side. Today, the smart grid was introduced as a solution to the increase of grid complexity and also energy demand. A smart grid differs from the traditional grid because it allows two-way communication of electricity data rather than one-way flow in the conventional grid system. Smart grid enable real-time data collection using the sensors and smart meter for managing the electricity supply and demand during the transmission and distribution process, and making the monitoring, generation, consumption, and maintenance more efficient. Additionally, smart grids integrate the action of all users in the power network using computer-based remote control and automation. This two-way interaction is what makes the grid smart, since it allows the grid to react. Generally, the smart grid consists of controls, computers, automation, telecommunication, and equipment that work together with the electrical grid to respond for the changing of the electricity demand. This slide shows some of the example of the smart grid application. For example, in a generation tier, the smart grid allow the variety of generation sources to respond on the quickly changing demand as necessary, especially to support the intermittent renewables. Okay, the smart grid will help to effectively connect all these power generating systems to the grid, provide data about their operation to the utilities and owners, and give information about how much surplus energy is feeding back into the grid, being consumed on site. On second one, on the distribution, smart grid enables an electric utility to remotely monitor and coordinate its distribution assets such as transmission line, substation, and etc., operating them in an optimal manner using either manual or automatic controls. The smart grid also provides outage detection and response capabilities, and sometimes also enabling the grid to self-heal. On the third tier, which is on the consumption, mostly on the consumer, the computerized in the home and appliance can be set up to communicate with the smart grid and respond to signals from the energy provider to balance the grid, also to optimize the energy costs. So why the smart grid is important for the renewable energy? Because it supports the intermittent of the generation and provide the information to the grid. So in the same time, it allows the adjustment of the generation and consumption to make the grid more stable and reliable. Okay, so this is the slide that's showing renewable programs in Malaysia. Just a brief about Malaysia in terms of the electricity mix. As of end of 2018, our total installed capacity is about 34 gigawatt, and around 77% is from fossil fuel, largely from coal and gas, and RE is nearly 23% of the national power mix, including the large hydro. In Malaysia, the pioneering RE program is the feed-in tariff, you can see, which was introduced back in 2011. And during that time, feed includes photovoltaic, biomass, biogas, and small hydro. However, after a few years, the price of solar has come down and it exited from the feed scheme. And now it's spawned to two other programs, which are the large-scale solar and also the net energy metering. Briefly about the large-scale solar is actually based on the reverse auction, and it is actually implemented by the Energy Commission of Malaysia. And the net energy metering for rooftop application is what currently being implemented by SEDA. The NEM scheme works with the energy credit from the excess energy generated by the rooftop solar. So for this P2p Energy Trading pilot, we utilize the existing NEM program and allows the energy access to be sold to other consumer with competitive price. Like I mentioned just now, the original NEM program is actually based on the credit base. So means that, for example, when during certain time you are generating about 20 and you are only consuming about 10, so means that there are 10 kilowatt of excess energy, and this is going to be credited. And when you can use this program, it's actually maybe during night when there is no solar, so this credit can be consumed back by the participant. At the bottom of the slide shows the financial option to install the NEM currently in Malaysia. Okay, so now let's enter into the P2P energy trading. Okay, this slide actually shows the benefit of the energy trading. And around the world, as we all know, that the P2P energy trading is currently being adopted to encourage the renewable energy. Some countries such as Thailand and Australia utilize the P2P for rooftop only, but other countries such as, for example, Austria, Netherlands, they allow other resources to be traded in the P2P energy trading platform. Based on our experience, this is actually depends. It varies of between each country, and because it depends on how the program be conducted, and also at the same time how the business model been run in the local. Okay. The key takeaway of the based on these slides actually P2P allow or promote more renewable energy, and also in the same time it promotes the transparency and reduce the cost. Why and how actually it reduce the cost, especially because of the transaction, the cost of the energy transaction be reduced, since the prosumer and consumer can deal directly without the man in the middle. Okay. And at the same time, also the P2P also there's a potential for the new business model, such as energy aggregator, that to introduce the virtual power plant and also the demand response management. Okay, and for those, for example, the one that, for example, residential that don't have rooftop space, so they may not have a chance to participate to install the solar. But however, with the P2P introduction, so they can buy from the excess energy that been generated by other producer. Okay. Next slide is actually to show all the P2P project around the world, and some of these actually still in the pilot project, and some already goes to live market. For this is actually in Thailand. They are actually conducted by the BCPG, and they are using a Power Ledger platform. We actually have visited them on last year on 30 August, and to get before we start with our pilot project, so we have chance to meet them and share their experience. Okay. So this is also in the pilot run still. This is in Australia. It's actually conducted in Fremantle. It's actually, if I'm not mistaken, it's actually joint venture project between a university and also Power Ledger. We also have chance actually visited for this project last time in Australia, and we met with Power Ledger itself and discussed about our project. And this is still in pilot project. So this is a Sonnen project in Germany. Sonnen is actually a battery company. So besides of providing the battery to the customer, they also provide a platform that allow the consumer, the generator, and also the consumer to exchange or to trade each other using their energy as a storage. And this is a Brooklyn project. This is also, I think, quite familiar around the world. This is also because it's based on the microgrid, so it allows between the peers to trade each other. And this is still also, I think, it's going to be live very soon. Okay, this is the nearest, or not really nearest, I think Singapore. We also have chance to visit with them. This is actually from Electrify. They also have came to Malaysia and discussed with us, and they are actually interested to participate as a platform provider. However, after some survey and discussion, we have chose Power Ledger as our platform provider. Electrify also, I think, still in pilot project yet. Okay, from all of these P2P projects, the key takeaways are shown in the slides. The key factors that contributes to the successful of the P2P energy trading are mainly to the tariff scheme, like how much actually been sold, the price set by the prosumer to sell to the consumer, because normally, and even currently what we are experiencing, that consumer only buy or interested if it's cheaper than the current rate. However, on certain cases, especially from the company that are looking for a renewable, they are willing to buy the energy even if it's higher than the grid tariff. In terms of the production, it requires the regulation to allow the energy trading between the prosumer and consumer, because, for example, in Malaysia, our electricity market is still regulated. Therefore, SEDA has decided to run a sandbox regulatory for this P2P energy trading. Okay. So why actually Malaysia is interested to move into this P2P energy trading? Firstly, it's actually this is actually based on our renewable energy transition roadmap study, and we found out that there is a high potential of solar PV rooftop installation as shown in the slides. So, however, most of this rooftop is actually whether it is in residential or it's also in the commercial. So that's why this P2P actually gives some motivation or some incentive for the public to install the solar rooftop and trading, and in the same time also can reduce their electricity bill. Okay. So these are actually the objective of our P2P energy trading pilot that actually currently still being conducted in Malaysia. Mostly, generally, it's actually to simulate, because based on what I mentioned just now, we visited Thailand and asked them about the experience. Yes, of course, on paper basis it's quite simple, but when it comes to the actual on the ground, it is not without a challenge. Okay, so other things that the objective of this pilot is actually to evaluate the technical and financial impact, because for example, in our project, prosumer always compare their benefit, whether they use the energy as a self-consume or whether they trade it to other peers. And in the same time, also this is also part of the identify the risks and challenges, especially on the agreement, how actually be an agreement, because the asset is actually belong to the prosumer, the grid belong to the utilities, and the consumer is actually using it, and they are using the utility company asset. Okay. And also at the same time, we are also conducting this pilot project to identify the regulatory changes. As I mentioned just now, we are still a regulated market, so we still need to have additional regulation that to allow the prosumer and consumer trading. And currently, we are working with the stakeholders such as Ministry of Energy, Ministry, and then also Energy Commission, and also Tenaga Nasional, which is our utility company, and also Power Ledger as the platform provider. Okay, so this is the concept of the P2P. The regulatory, because just now I mentioned we don't have, we are still regulated, so we need a sandbox regulatory. And it essentially was approved last year by the Energy Commission, commencing November 2019 until supposed to be June 2020 to be completed. However, due to the movement control order, which is under currently COVID-19 pandemic, most of the consumers are expected to consume less energy since they are not allowed to operate their business. Thus, we have postponed the beta phase for probably about 3 months. We will actually looking into the trend of the energy consumption, whether they are going to back, because currently Malaysia already under conditional movement control order, CMCO. So all the business can start operate back with approved standard operating procedure. So in this slide, you can see that how actually the prosumer generate the energy and then send through the electricity, send the electricity through the utility grid, and then consumed by the consumer. For this pilot project, actually we have divided into 2 phases. One is actually alpha and second is beta. Currently we are in the alpha phase, which is actually only on more using a real data, but on more on just a paper base without a commercial transaction. And we anticipate to start back the beta probably on June, if based on the survey that we have received last week, that most of the consumer and prosumer declared that they are going to be 100% operation by June. But we will see the data from their meter based on their consumption and generation. So how actually the P2P actually operation is actually based on the smart meter. Is one of the most important component that required for this technology. On both sides, on the consumer, the energy meter will capture the energy consumption, and on the prosumer it will capture on the generation. So both of this data actually will send to the power to the P2P energy trading platform. And what actually this P2P energy trading platform function is actually to do the matching and also to process the trading. Okay. Some area call it prosumer, some area call it producer. It's actually same. The party that actually generate the energy, the green energy. Okay. So so this is the snapshot, one of the snapshot that for the trading by platform by the Power Ledger. So what we can see now is actually there are green and also the gray. The green is actually purchased from the peer, and also the gray is actually purchased from the grid. So it depends on the generation, whether the most important is actually to match the profile, because for example, we have tested several profile of consumer that need to be matched, because some of the consumer only operated during weekend very high, and during the normal day they are very low. And but for the prosumer, sometime because this is NAM, so the character of the NAM is actually they will self-consume first, then the excess energy only been sold to the consumer. So taking into this consideration means that during the weekdays, most of the prosumer will self-consume first because they operated it fully, and only on during weekend only when they don't operate their business, then only there is an excess energy to be sold to the prosumer. So this is part of our challenge, that we need to find a suitable consumer to match with the generation. So with this platform, actually what we provide, actually we show that how much actually been generated by the prosumer and how much actually consumed by the consumer. So both sides can see their individual data or information. So for example, for prosumer, they can see who actually bought from them, and for consumer, they can see who actually sold to them. But for us as a host, application host, we can see both. And in the same time, the utility companies in this project is actually a TMB. They also have the access to see, because after the trading process completed, the platform will generate the summary of the trading, and we will forward it to the utility company to do the settlement, to ensure or to guarantee the collection of the payment from the consumer. So the billing, the TMB billing is used and actually being calculated inside the bill. So the consumer don't need to pay multiple platform, and they just need to pay on by their existing bill. And for the consumer, they also get the payment by offsetting based on the payment that they receive from the consumer bought from their energy. Okay, so this is the list of participants that participate in our project. Basically, it is still changing, because it is based on how actually the energy profile can be matched. So for example, from time to time, some of the prosumer may feel that it is a risk for them, so they pull out from the project. So this is the list as of February, 17th February. And latest one, we will know that after this this MCO be lifted, so we know the final list, and to be entered into the beta, which will involve the commercial transaction. That's why previously, during the alpha, it is not much risk, because they just need we just simulate their trading based on their meter data. But entering into the beta phase, it involves some risk, especially on the non-taker energy that generated from the producer or from the consumer. Okay. So this is a summary of our trading during the alpha. Since we have started it since November until February. This is the latest on February. We are yet to generate the analysis for during the MCO, because during this MCO, most of the meter reading is not being done on site, and mostly it's already been doing on remotely. So we are still on the process of analysis, and hopefully it can be completed very soon. Okay, so out of this project, just to share with you all, these are key challenges for us to complete this project. And first of all, it's actually the smart meter infrastructure, especially because to avoid any dispute of the meter reading, and also to reduce the cost, we are actually using the existing smart meter that been installed by the utility. So one of the requirements to participate for this pilot project is the site itself must be installed with the smart meters. Okay, so in the same time, with the smart meters, which already been operated in the existing utilities company platform, we have to import the data and push it to the Power Ledger platform. And this is where the integration is very important to ensure that the smooth transaction, especially to ensure the settlement can be done smoothly. This is also actually the experience that we learned from Australia and from Thailand project. And second one is actually just now I mentioned, the challenges is actually to match the profile between the prosumer and consumer to ensure that optimized trading can be done. And the last, the third one, not the last actually, this is actually more on the keys challenges. Is actually to optimize the energy trading algorithm. For example, certain platform allow that the energy being traded as a dedicated. For example, Prosumer A generate and they want to sell everything to Prosumer B. So anybody that want to buy, they are not allowed. And some of the it depends on how actually we design it. So for us, actually we created it as a pool. So anybody generate, we actually we are following actually Thailand and Australia model. So anybody generate, you will sell into the pool, and during that time, anybody who is actually currently consume it will can buy directly. And in terms of the who actually will get which energy going to be sold first is actually depends on the rules. Some say that depends on highest price that offered by the consumer or cheapest price offered by the prosumer. It actually depends. For us, for in Malaysia pilot project, we use the cheapest price offered by the prosumer. Okay. Okay, I think that's all from my side. I pass back the stage to moderator. Thanks.
Okay, thank you, Mr. Hazril, for your very insightful presentation. So I think that P2P is now conducted in many countries, and then in each country they have their own challenges because
Correct.
the different of energy use and regulation like that, right?
Regulation. Correct.
And so in Malaysia, I think the P2P trading is now currently done by using a solar PV, right?
Yeah. Currently, we only use for solar PV rooftop under the net energy metering program.
Maybe is it possible to use another source of renewable energy to
do the P2P? Yes, correct. For example, in Australia, in Austria and in Austria and also in Netherlands, they allow the wind and also I think the wind and biomass, so the biomass and biogas to participate for this. That's why it depends on how actually the model, the business model itself, because some of it is actually the consumer can choose directly which resources they want. For example, they are interested to contribute for PV, so they can choose it. Or they want to contribute for the biomass, they choose it. Or they maybe know some of their friends or family actually been generating the energy, so they can also buy from them. It depends on the platform features actually.
Okay. Thank you, Mr. Hazril. It is very insightful and it's very beneficial for us and for we as Indonesian, we can learn from the Malaysian project and then the Thailand and other countries that you've stated before.
Okay, sure.
Thank you. And then talking about solar PV, we have Miss Annisa Hairani that we're going to present her presentation about solar PV. Miss Annisa, are you there?
Yes, hi, thank you.
Okay, so maybe we can just go to your session. So the time is yours.
Okay, thank you. So first of all, thank you for inviting us to participate in this webinar from NYSRE TV. So it is nice to be acquainted with Mr. Hazril Izan Bahar from SEDA as well, along our journey in solar PV in Indonesia. We heard a lot and we read a lot of publication from SEDA. So today's topic is what I know is about the smart electricity. So after hearing materials from Mr. Hazril about smart electricity and smart grid P2P transaction in Malaysia is highly driven by excess energy from PV rooftop. So probably in today's session, I would like to tell a story about what we have we done so far for solar energy development in Indonesia. So the outline for today's presentation that I have prepared is probably a small introduction about TML Energy and what have we done so far, and then probably a small knowledge sharing about solar energy as well as types of PV system, the application in Indonesia, as well as other general information. So TML Energy is basically an EPC company with the legal name of PT Tritama Mitra Lestari. Our business was founded in 2011. Our office is located in Bandung. We don't have other offices outside of Bandung. And we are working as an EPC specifically for a solar energy system in Indonesia. And then this is what our core business are. So we are working at first in construction for solar energy, small wind energy system, as well as other electrical and electronic applications. And then we go to a service business, whereas we offer our clients to do studies, whether it's feasibility studies, grid studies. Also, we have operation and maintenance program for PV power plants in Indonesia, and we also have a retail business, whereas we provide a residential rooftop system for peoples in Indonesia, obviously in urban areas. And then the outer layer is where we aim to be. So we would like to be an energy company in Indonesia and have a long-term electricity contract with our clients. And then this is what our business flow and activities so far. So we would like to be a one-stop solution for our customer, whether it's in initial engineering or a project execution, or even if they already have the power plant, we can do operation and maintenance. And this is our company experience. So from 2011 until today, we have built more than 200 locations throughout Indonesia, from Sumatra to Papua. With a total capacity of already in operation today about 18.5 megawatt peak. And also we have done some studies for a PV power plant in a total capacity of 10 megawatts. So a brief introduction about solar energy. So as we know, and probably a lot of you are college students, so probably aware there are two types of solar energy. So the left side is centralized solar energy, whereas we collect the heat from the sun to heat the water, and then when the water is evaporated, created like some sort of what is a steam, and then it can move a turbine. And then on the right side, this is what we call the photovoltaics. So TML Energy are focusing for the technology on the right side, which is a PV application for solar energy, creates electricity. And this is how it works. So it's not best for me to describe this, how PV works, because I'm not from electrical engineering. So yeah, so basically the PV panels are capturing the irradiation from the sun, and then it turns those lights into electricity. And then this is some types of solar cells available globally. There are two different types actually. The first one is crystalline silicon cells, and the other one is thin film cells. The thin film cells is the one that are more bendable, so it can be molded into some shapes, while crystalline silicon cells is more like already fabricated one, so it's like the usual panels that we look today is mostly crystalline silicon cells. And in the crystalline silicon cells also have two types. There are polycrystallines and also monocrystallines, where polycrystallines is in these pictures is more like a bluish color, while monocrystallines is more to the black colors. And then this is a typical installation. We have mentioned a lot of rooftops today. So typical on-grid or grid-connected installation for rooftop systems, basically like this. So you only need two main components, which are the panels, the solar modules, as well as the inverters. So the inverters using to invert, because the PV system are creating DC electricity, so you need inverter to convert it into AC, because a lot of electricity in houses and buildings is usually using AC. And then we have AC panels to connect the output of inverters to the distribution grid, or housing panels probably. And then also the one that are very trendy currently is using the export-import meter. When you have a rooftop PV in your house, and you can use export-import meter from PLN to have your excess energy being credited into your bills. But there are a regulation here in Indonesia that limited only 65% of your electricity that exported to the grid to be credited in your bills. So this is probably quite a challenge, because it only appears in 2018. So the export-import meters initially comes in 2014, whereas 1 kilowatt hours equal 1 kilowatt hours from PV rooftop equals 1 kilowatt hours tariff from PLN. But currently the regulation have been changed in 2011, becomes 1 kilowatt hours output from your rooftop panels equals 65% of 1 kilowatt hours tariff from PLN. And this is a basic components warranty. So what are the warranties of the components that you installed in your house for rooftop system? PV modules itself, they have 10 years product warranties. And also most manufacturers have 25 years performance warranties for PV modules. The performance warranties means that at the end of the years 25, your modules still produce 80% of their power output. And then for inverters, the warranty is 5 years, but it can be extendable to 20 years from several manufacturers. And module mounting structures is the racking system to install the PV modules into the roof. This also have a warranty of 10 years from the manufacturers. So basically, rooftop PV is a long-time investment. And yeah, it's really required some extensive warranties to make sure that it holds its purpose until 20 years. And this is only the illustration of 1 kilowatt PV systems equals to in terms of reducing greenhouse gas emission. So annual solar production per kilowatt PV system equals to 1 ton of CO2 greenhouse gas emission avoided. And this is the illustration of what are the irradiation irradiation from the sun that available in Indonesia. So the redder it gets, the better the energy output from rooftop will be. So as you can see, the eastern part of Indonesia is usually have better irradiation than the western part of Indonesia. And then this is the other application for a rooftop PV. So there are 3 types of roof based on our experience here to install a PV system in buildings. So the first one is for residential system, where it's mostly use tile roof. Usually needed a bracket some sort, looking like this. And then another types is metal sheet roof, usually common to be used in commercial and industrial sectors. And also concrete roof. So for concrete roof, you need extra ballast to keep the modules in place, so it's not going to be blown by the wind. So this is the type of mountings that we use. This also for concrete roof, but instead of using ballast, this one is drilled down to the roof. And in terms of challenges, so other segments have their own challenges. In terms of residential sectors, of course, the market is increasing with the application of export-import meter available from PLN, but it gets slowed down due to change of regulation to 65% of tariff. And then other challenges that we have come across is the application process to obtain the export-import meters from PLN seems to be different from one PLN area to the others. And also other challenges for homeowners is to make sure that when you want to install the rooftop PV, you need to make sure that you have no shading on available roof area because it can decrease the output energy that you get from the rooftop. And then for commercial sectors, this pictures is taken in Tokopedia. So we have done parking canopies for them. So in terms of commercial sectors, the challenges are the available roof area is very limited, especially in high-rise buildings, whereas the electricity consumption is very high, but a very little roof area that can be installed with PV. And then some other challenges is for the roof structures, which are not prepared for PV addition because the buildings has been there for probably 30 years or 40 years time, and it doesn't design to have a rooftop PV on their roofs. And usually the weight or additional load for PV system is between 10 to 20 kilograms per meter square. And also the next segment is industrial segments. So some cases for industrial sectors, because our industrial parks have been there since the 80s or the 70s, there are a lot of old buildings. And some cases they will need roof restoration or rejuvenation before we can install rooftop PV in their premises. And the other challenges is from the regulation, because we have a restriction for parallel operation in industrial sectors called capacity charge. You need to pay capacity charge for PLN if you installed additional rooftop in buildings with industrial tariff. And then there's still no export-import meters available for industrial sectors, especially with capacity above 500 kilowatts from PLN. And this is the pros and cons of using ground-mounted or roof-mounted. So for ground-mounted, I mean, is looking like a solar farm installed in the ground. It is easy to access and easy to clean. While roof mounted, in terms of the investment cost, rooftop is less expensive than ground mounted. But since it is installed in roof, so it is quite tricky to do maintenance. And then for ground mounted, the system is not limited to the area that you can use. So if you have a lot land that can be covered with PV, then there's no problem. Whilst for roof mounted, you are limited to what are the areas that are available in your roof. But rooftop requires fewer materials to install because it doesn't need additional surfaces surfaces installed like control house or probably a pathway to clean or additional plumbing to do maintenance, etc. And then ground mounted, the panel temperatures will be cooler because there are nothing below the modules. And whilst roof mounted, since the panels are is not really directly, is like a few millimeters above your roof, so it probably can create some heat if it is not installed properly. But it utilizes unused space because you're not using your roof to place anything, so you can install rooftop PV in there. And then also rooftop insulation is added insulation and protection to the roof. So especially in industrial areas, less less carbon dioxide produced or less pollution it produced. You don't need to change your roof like every 5 to 10 years with PV installed in it. And then this is the other information for PV application in Indonesia. So what are the cost structure and lead time to generate a PV system? So basically, for capacities above 100 kilowatts, we usually need from 4 to 6 months lead time from getting the equipment and then deliver the equipment on site, doing the construction, and then doing the testing, commissioning, and also for houses to obtain the export-import meters from PLN until you can generate electricity in your house. And then what are the options for purchase? So there are two types of purchase available in Indonesia to have a rooftop system in your building. Whether is it a full purchase, whereas you buy as a capex or as an investment, and the other is using a leasing scheme or rental scheme. This is quite trendy right now because buying in full purchase, usually the initial investment quite high. That's why people are moving towards a leasing scheme to have the electricity from solar energy with zero down payment. It's like installment scheme, like you're buying a car or buying a motorcycle. So yes, so this is only the project documentation that we have done so far. So this is what it looked like to have a solar farm. This one is in Maumere, East Nusa Tenggara. This is 1 megawatt peak that we have done. And then also another ground mounted system. This one is a microgrid system. So it consists of PV panels, batteries, as well as a diesel generator. This system is constructed for a mining company in East Kalimantan with 3 megawatt peak PV. And other application for PV system is for floating solar. So we have done a 60 kilowatt floating solar at a mining void in North Kalimantan. and this is what it look like for industrial rooftop. So it is high up the roof. This one is a concrete roof in Cikarang Listrindo, and this is a typical installation for a standalone system. So this one is the system that you come across in remote areas, whereas there are no grid available from PLN, so they use solar PV to give electricity for a small village and the areas around. And this is also other types of rooftop system. The left side is on furniture of a furniture store in Kemang for Bika Living, and the other lab is in Universitas Indonesia in technical faculty, I guess. And this one is one of the largest rooftop in operation in Indonesia, is 1.4 megawatt in a motorcycle manufacturer in West Java. So, and also we have installed for 1 megawatt a residential system in Cilacap areas for Pertamina. So this one is in a residential complex where there are probably about 30 to 35 houses installed with a total capacity of 1 megawatt. And this is another application for using PV. So we can use it for electricity for charging station, EV charging station, whether it's car, bicycle, and or else. And we can also use it for a solar street light. And the right below side is container office. So it's an office powered by solar PV and batteries for exploration, mining exploration, or others. Yes, so basically that's what have we done so far. So probably that's all from TML. I will give back the time to moderators. Thank you.
Thank you, Ms. Annisa, for the introduction from the solar PV produced by TML Energy. It is a very amazing project you've got. And in ITB, we also have some buildings that using solar PV, like there's a laboratory using that in the roof, and then there's also
yes, actually that's also one of our projects in ITB. But yeah. But I haven't
cool.
got the pictures yet, so sorry.
Okay. Okay. So I've seen the chat room, like everybody is excited with this. And then maybe we can just go on to the Q&A session, maybe?
Okay.
Okay, so for Miss Annisa and Mr. Hazril, can you turn on the camera?
Yep.
Okay. So first one, there's this question from Ahmad Ramdhani for Mr. Hazril. Does the house need a certain specification if we want to use P2p trading?
Okay. Is there any specification? It depends, because just now I mentioned the P2P is actually for Malaysia. It relies on the NEM program. So means that they will self-consume first, then only the excess energy will be sent to the grid. But in Australia, they are actually using the feed program. The feed means that 100% of the energy generated is going to be exported to the grid. So in terms of the standard or design, it depends for whether how big the rooftop space is, or for example for the NEM, it depends on the capacity capping limit. So if the program is actually limited to, for example, 65% of fuse rating, so the installation can only go up to that maximum size. So to be specific, there is no. I would say that there is no any specific for the installation size for the rooftop of the building.
Okay, thank you, Mr. Hazril. And then for the next questions, also for Mr. Hazril, from Arvianto Nugroho. What if the supply electricity is less than demand? How is your coordination with centralized generator? Because most of centralized generator, like coal power, need long time to start up.
Okay, so this is where that we need the information of the generation and also the consumption. But in the same time, because for example, in our household, they are only single connection to the grid. So whether they are actually supplied by the P2P, or they are also can be supplied by the grid or from the existing one. Since the P2P size is still quite small, so it does not really impact to the grid stability. Means that there is always a backup supply from the grid itself. Because as we know, for the PV, it always depends on the sun. So, for example, during certain time there is a cloudy time, so the generation will be low. So during this time, the electricity will be supplied from the grid. Just now that I shared the slide, that is showing that there is a gray bar, and also at the same time there is a green bar. So the green bar is actually supplied from the P2P if there is any excess energy generated from the participant, and the gray is always a top up from the grid itself.
Okay. Thank you, Mr. Hazril. And for this question from Stasia, also for Mr. Hazril, how this P2p energy trading system can send the excess energy directly to buyer that customer want to sell. How does it work? And how about the issue of security? Because smart electricity meters can be dangerous, insecure, because the hackers can cause fraud, explosions, and house fires. How you manage this security?
Okay, in terms of the security, just like I mentioned, it's actually rely on the utility, and normally the utility always have their private network to communicate with the smart meters. So what P2P do is actually the platform actually tapping or actually connecting to the existing virtual private network of the utility companies, and they just pull the data from their data center, and it always sharing about the information of the energy generation. So in any case, if the hackers want to enter into the smart meter, they have to go through first into the utilities, and which is actually introduce a bigger problem, and it need to be, I mean, to be considered by the utility company itself. But in terms of the P2P, most of the P2P platform actually been using blockchain technology, which actually reduce the risk of the tampered data, because it's always been blockchain. In the same time, also it's actually the data is always been replicated to other nodes to ensure that the transaction is actually genuine and transparent.
Okay. Thank you, Mr. Hazril. Okay, that's for the first term. So the link for the feedback is on the sticky notes. There's also the password. Please follow the instruction, read it, and then if there's a problem, please contact the contact person that is applied on the form. And then for the next term of Q&A. We'll be asking Miss Annisa. And this question is from Pijar Fitra Ababil. Is the treatment needed for the solar rooftop systems complicated for people that doesn't have any basic education for the system? And how about the cost for the annual maintenance?
So the easiest one is to answer the second question first. So operation maintenance is very low for a PV system. It's close to none, because if you can do it yourself, so you don't have to pay other services to do it. So basically you need to clean the panels from debris or from bird droppings and some sort, so you can get maximum energy yield from it. And it doesn't have to do very frequently. You can only do it like twice a year is sufficient enough to keep the energy yield optimums, unless you live next to a high pollution high polluted area. So probably once a month cleaning is sufficient. And in terms of installation, whether you need to have certain technical expertise to do it, I think it's better because, as I said, it's a long time investment. It's better to be installed by certified personnel rather than doing it yourself. But it's not really something that is very hard, because PV panels is, even if you're lying it outside on the road, it can generate electricity. So, but more to a safe term when you install it in the roof to prevent any fire in the next following years, and to prevent short circuit and electrocuted yourself. Probably it better to be done by certified personnel.
Okay, thank you, Miss Annisa. And then for the next questions from Fajri Zulfikar Rosmana. How much the electricity bill can be reduced by the use of solar PV? And how long the return on investment capital purchase this solar PV?
It's also for me, the question?
Yes.
So, based on our experience, if it installed in residential areas for houses usage, so it highly depends on the electricity usage in each buildings. If you have 4 sets of air conditioner in your house and everything is turning on 24 hours a day, so it's probably you will not save much from installing PV rooftop in your house. But for normal electricity usage, our customers' testimonies said it can lower their bills from 40 to 60%. We have one cases of 80% savings, but it's unusual case, a special case. So, but normal between 40 to 60% savings.
Okay, thank you, Ms. Annisa. And then this last question is also for you. It's from Ratu. As solar PV systems are designed for 20 years of lifetime, how is the waste treatment from the panel that has been used for 20 years?
So the beginning of PV system in Indonesia is, I don't think there are any power plant that have reached 20 years or 25 years yet. But from what I've gathered in Europe, or probably Mr.Hazril can also help, because Malaysia also, SEDA have done a lot of research on it. But you cannot recycle PV modules because when you recycled it or you open it into smaller parts, divided into smaller parts, it can be carcinogenic. So the best way to deal with the waste is to return it to the manufacturer, so they can remove the parts that are not available to be used and reuse it into something else. So it can only be reused but not recycled.
Okay, Mr. Hazril, you want to add something?
In terms of the recycle, yes, in Malaysia so far, we also quite, I mean, the installation for the solar PV is quite new, and so far we haven't received any request to recycle. But for others renewable project, for example, for the biomass, because we have some tenure renewable energy power purchase agreement, so for that, yes, they can always reapply back, whether to join back as a feed-in tariff program, or they will just get into the wholesale market to bid with the common price.
Okay, so that's for the second term. Excuse me. So, okay, so the link for the feedback form is only available when the webinar ends, and then the links is on the sticky notes on the chat room. You can also access it. There's also the past. Please remember to read the instruction carefully. Okay. And then maybe we can go, because there's still time, maybe we can go for the next termin. This is the questions from Ahmad Hafiz Rido. So, I'm a marine engineer. I have a plan to make a research about environmentally friendly vessel that powered by solar. I heard from several journals that photovoltaic efficiency is less than 20%. Is the efficiency of the PV can be upgraded by doing some modification on its inner components? And will the PV survive from shaking and seawater salt? Thank you. Maybe Miss Annisa or Mr. Hazril can help.
So probably I can respond about this. So because TML also have like we have created before last year TML Energy Green Challenge. So probably some of the college personnel already know. So we gathered ideas to have like some sort of research on what are the application of PV that can be used in the following years. So one of the idea that we come across is for marine vessels. So PV probably is in terms of efficiency of PV modules is related to the area coverage of the panels. So it's not really related to the output of the energy from PV. So higher efficiency means you can install lower amount of PV panels to reach the same capacity. So 1 kilowatt peak with 20% efficiency probably only required 7 meter square areas, whilst 15% efficiency will require 20 to 21, or require 11 to 12 meter square areas. So the efficiency of PV panels is related to that. So I don't think you can change anything within the panels itself to increase the efficiency of the panels. But in terms of shaking in vehicles, probably it best to reduce the vibration of PV modules if it will be installed in the vehicles, because vibration in a long term can create a micro cracks that will lead to decreasing energy yield electricity from the panels. I think that's what I know so far. And what are the challenges to install PV panels in the vehicles? Probably Mr. Hazril can add some.
From my understanding, because I'm not background of the engineering, but what actually my experience, yes, the efficiency of the energy that can be captured by the module is actually depends on the material. For example, between the poly and also another one is actually polycrystalline, and also I think I can't remember the other one. And when people actually doing the installation, this is always what they are considering, especially for their ROI. For example, if they are installing the low efficiency one, means that with the certain square feet of installation, they can only generate certain amount of energy. But if they they invest a little bit more and they get a better module with a slightly higher price, they can generate more energy and they can get less of return of investment. So in terms of how actually make it to become more efficient, for example, some of the proposal that we receive, they are also currently in the technology that they have both side solar panel, means that they can capture from top and also from the below. This is still under R&D yet, and also for example, there are also way of that actually they are combining between the solar PV and also the solar thermal, so that the thermal pipe can actually reduce the heat of the module and can increase the efficiency of the module itself. That's all.
Thank you, Mr. Hazril and Ms. Annisa. So basically that solar PV is now is still on research and development for many conditions, and there's still no limitation. You can do anything, I guess, but it's still in the research. Okay, for the next question, maybe it's for Mr. Hazril. Is a mini grid required a P2p energy lending, or is it possible without it?
Essentially, it really does not. I mean, for example, in the Brooklyn, the project is actually on the mini grid. The reason why, because they want to promote the renewable energy. So between the residential in that area, actually they agreed to buy from each other. So that's why it depends. For example, also we have received some proposal from this is actually to be implemented in Ireland, because in Ireland they have some difficulties to get the power supply from the mainland. So how actually they want to promote that people to increase their installation is by using this P2P, so that the producer have a motivation or can have make profit by installing this the solar PV. And how actually they're going to trade is actually using the P2P. So my answer is actually it depends, not really must. So it depends on how actually the agreement between the peers actually.
Okay. Thank you, Mr. Hazril. And then the next questions, maybe Miss Annisa can answer this. This is from Muhammad Aditya. Is there a rejection case of this client as the geographic condition? For example, client's site place has no optimal radiation of sun and yeah.
I don't really understand what the rejection means, but so the irradiation from the sun is related to how much energy that you will get by installing PV rooftop. So it only relates to how much savings that you can get. So in higher irradiation areas like Surabaya, or probably in eastern part of Indonesia, in Kupang or else, you can get probably 5 hour time sun, while here in Bandung or Jakarta, you can get like in total 3 to 4 hours peak hour of sun. So it difference if you buy it for your house, so the difference will be in the break-even period of your investment.
Maybe maybe the question is like, have T.En.Hazril like reject a client because of the geographic condition? I think
No.
that's the question. Okay.
Yeah.
Thank you, Miss Annisa. And
Yes. Because even though in Indonesia there are some of yellow area of sun irradiation, it is generally higher than any part of the world, like in Europe, in England, or some sort. There are green areas in those countries. So in Indonesia, well, we're close to the equator, so the sun is practically here every day. So we don't have like a coldy winter with no sun at all. So basically, even if it rains, it can still generate electricity.
okay. Apparently that we still have time, and maybe we can go on to answer more questions that have been coming in. This questions is for Mr. Hazril. Is it possible to implement energy trading while the regulation only set the price of excess electricity by 65%?
Okay, 65% of the capping, if I'm not mistaken, correct?
Yeah.
Yeah, okay. The 65% capping is on the installation side. Same in Malaysia for the NEM installation, there's a capping for 65%, but not every time that the energy will always be used. So certain time, for example, during lunch or maybe during weekend, the energy will not be consumed by the user itself. So this is where that the potential of the excess energy can be exported or to be traded. But in terms of the capping itself, it will actually will not allow, it will not encourage to be, the energy to be exported on the normal time basis, because the 65% normally is actually designed to be self-consumed. So this is actually based on our experience from the NEM and the P2P.
Thank you, Mr. Hazril. And the question from Fadila. If we want to attach solar PV on our rooftop, should we need any permission to any local government or PLN, and how much saving that we will get? This is for Miss Annisa.
Yeah. So in terms of saving, is similar with the last question. So basically depends on the energy consumption on the building or in the house itself. But generally speaking, it's between 40 to 60% savings. But for in terms of permitting, you don't actually have need to have an approval from PLN or other government entity. But in terms when you need to apply for export import, you need to tell them in advance. You need to tell PLN in advance that you would like to install a PV rooftop in your house and what are the capacity that you will be installed, so that the export import meters is already available when the installation is complete.
Okay, thank you, Miss Annisa. And then for the next questions, from Radityo Fajar. For the residential SIM, what the best option for customer to install PV system, off-grid or hybrid, and why? And how about the integration to PLN grid issue due to PV has voltage and frequency fluctuation and also harmonics.
So I don't really know the electrical terms because I'm not an electrical engineering, but rooftop PV use one of the main component of PV system is inverters. So the inverters will be the one that will organize everything in your system, whether is it to have the same configuration with the grid available, whether is it PLN grid or a diesel generator grid. So the inverters are making sure that the energy that comes from the PV system are in sync with those grid and will not harm any electrical appliances in your house. And then what are the next question? I'm sorry, the other one.
For residential scheme, what the best option for customer to install PV system, off-grid
Best
or hybrid?
option. So if you would like to have an export-import meter, you cannot have other system other than on-grid system, because PLN will only give you the meters when you install grid-connected PV rooftop. But if you like to have a backup battery, it can also be done. But in terms of the investment, system with battery will highly cost more than a system without batteries. So the key element here is in the batteries, because the cost for batteries is probably even higher than the actual PV rooftop system, on-grid rooftop system.
Yes, normally the residential is always on grid because it needs a backup when there is no generation or maybe there is no battery.
Okay, thank you, Miss Annisa and Mr. Hazril. Okay, and then so on to the next questions from Oziano Tarigan to Miss Annisa and Mr. Hazril. Should the government give mandatory implementation for upper class to use smart electricity?
Okay.
Maybe-
Maybe I try to share. Okay. In terms of whether it becomes mandatory or not, it still depends because we have to look into the other angle, which is once the government make it as compulsory, so there is a possibility that the price of the so that's why it depends on the objective of the program, whether if we want to promote it, so it can be also be done by other way. For example, by using a levy system, so that certain people with a certain consumption are very high, they should pay certain levy to contribute back to the growth of the renewable energy. So that's why in terms of imposing or making it compulsory, this need to be studied properly, or else it may end up become overpriced or very high demand, or suddenly everyone is actually need to compulsory.
Okay. Miss Annisa, would you add some?
In terms of mandate, I don't think government needs or should mandate like higher class to have a rooftop, because again, rooftop is an investment, so you need to buy the components. Yeah, their value of it. So if it mandated, I don't think people will take it positively. But it depends on what are the issues that the government are looking for. So if it to reduce carbon dioxide or greenhouse gas emissions, yeah, it probably best to have like some sort of incentive. So about it for government to give incentives rather than to mandate people to buy or have a rooftop system in their houses.
Okay, thank you. Okay, so we can continue to the next questions. Okay, maybe this is for Mr. Hazril. So what are the biggest challenges for Malaysia while do groundbreaking to implement? Can you give us, as a student, the key of success to help Indonesia implement smart grid?
Okay. When we talk about the smart grid, for example, the challenges that what I have found is actually the investment itself, because to replace the conventional grid to become a smart grid, it will cost you. So, so how whatever it is, how actually we can achieve this actually, whether we can go by the regulation. So it means that somebody needs to lead this project to, for example, to have a national smart grid blueprint, so that other parties can see the forecasting of how long it will be, and other people can also prepare to adopt the technology. And also in terms of P2P itself, the one of the most challenges for Malaysia, for example, because currently we are still a regulated in electricity market. So the challenge actually to open this market, and it is involve many things, especially the tariff scheme itself, because currently most of the electricity tariff is actually being subsidized by the government itself. So when we want to open it and to make it liberalized, so there is a possibility of the increase of the tariff of the electricity, and the electricity is actually a commodity for everyone. So besides of the increase of this, it also will may impact to others. I think so far that's my opinion on that.
Okay, thank you, Mr. Hazril. And apparently, this could be the last questions for Miss Annisa. This is a question from Alfie. High upfront costs always be the problem for renewable energy development in Indonesia. I have heard about Sun Company credit financing. Do we have other financing option for this? If not, why?
Yeah, high upfront costs is been the problem the last 5 years. So, but probably since last year, a lot of PV rooftop providers have engaged a partnership with banks or insurance company to make sure the leasing scheme or rental scheme or installment scheme are available for people to have a rooftop PV. So in general, like TML, currently we are working with the UOB Bank. So you can buy a rooftop system or procure one with credit card installment with 0% interest, or else we also have developed some use solar program, whereas UOB Bank can give a financing for people to have a rooftop PV with the maximum of 7 years financing. And probably also there are developers other than TMLs like Sun or Surya or else that can also provide another scheme of installment or leasing or rental scheme for PV rooftop Indonesia. So basically there's now a lot of financing scheme out there.
Thank you, Ms. Annisa. And as that's the last questions, maybe Mr. Hazril and Ms. Annisa could give a closing statement to end this session. Mr. Hazril, maybe you may go
Okay,
first.
okay. All right. On behalf of SEDA Malaysia and from me itself, I would like to thank ITB for conducting this session. And I learned a lot actually today especially from Ms. Annisa presentation and about the electric PV industry in the Indonesia. And I'm also glad that we have chance to share with our experience. So feel free anytime if you have any more question, please contact me. I'm not sure whether my email address will be shared with others or else just Hazril, Hazril at seda.gov.my. You can email me if you want to share or to ask any question. Thank you.
Thank you, Mr. Hazril.
So from me, I would like to thank you, Social Renewable, Society of Renewable Society of Renewable Energy ITB to invite us to participate in this webinar. So, and it is nice to see hundreds of attendees. So it is nice to have college students are interested now with the renewable energy, especially in solar PV. And also, thank you, Mr. Hazril. I've learned a lot that Malaysia are currently have a P2p transaction in development. We are highly wishing and hoping that Indonesia can come there soon to join you in P2P transaction. And yes, so probably for the attendees that still have some question about TML Energy or probably interested to cooperate or have ideas or want to have a knowledge sharing, please don't hesitate to contact us. We are also close by. Our offices in Bandung is the same city with ITB. So yeah, probably that from me. Thank you.
Okay, thank you very much for Mr. Hazril and Ms. Annisa for sharing with us the insightful knowledge about smart electricity, solar PV, and P2P trading. So we've reached the end of the webinar session. I would like to thank you for all the attendees that joined us today from the beginning. And then I would like to say it's nice. It's really nice to see how you are very motivated by renewable energy and all the developments. So I would like to see all the attendees on the other session of Energy Week. And then I'm sorry if your questions didn't get the chance to be asked to Mr. Hazril and Ms. Annisa, but as they say, you can contact them, and then maybe later the contact can be shared to all attendees. So for the feedback form, will be maybe there's some problem and we are still in maintaining it. So you can wait for the next information. That's all. And then thank you for joining Energy Week second day. And please have a nice day and have a nice iftar later. Okay. Thank you.
All right. Thank you.
Thank you. Bye bye.
Bye bye. Thank you very much.
Stay safe, everyone.